ultrasonic entity, how the non-destructive testing, how the legal metrology implications have for inspection accuracy. We have with us Dr. Piyush, who is a postdoctoral fellow in the University of Memphis, USA. He has done his PhD from National Physical Laboratory, New Delhi. Sir, thank you very much for accepting our request. Am I audible to you, sir? Dr. Piyush.
Yes, sir.
Oh, thank you very much. Thank you. Dr. Piyush is a postdoctoral fellow in Department of Mechanical Engineering at the University of Memphis, USA. He earned his BSc in physics from DU, Delhi University. He subsequently achieved MSc in physics, specialization in electronics and condensed matter physics from Kurukshetra University, and PhD for the thesis design, development, and study of instrumentation for ultrasonic pulse velocity measurement at National Physical Laboratory in New Delhi. His research focused on ultrasound, NDT, and scientific instrumentation. He has developed 5 instruments and 2 software programs. Congratulations. Related to ultrasound technology, he holds 1 US patent, 1 Indian patent, and 1 software copyright. One of his technologies has been transferred to industry for commercialization. He has released 3 reference materials for the calibration of ultrasonic pulse velocity testers. He has published 5 research articles in international journals and 1 IEEE conference proceeding. He has presented at 2 national and 3 international conferences and participated in 6 national and international conferences. Additionally, he has contributed 6 book chapters. He is an associate member of Ultrasonic Society of India and a student member of the Metrology Society of India. He has exhibited his technology at 4 exhibitions. He has received several awards. He has qualified NET, GRF, and lecturership assistant professor joint CSIR UGC NET GRF 2018 and qualified for the GATE in 2019. And he has awarded Dr. M. Pancholi Memorial Award by the Ultrasonic Society of India in 2022. He also won first prize in the poster presentation at the poster symposium held at National Physical Laboratory. Thank you very much, sir, for accepting our request to enlighten us with your vast knowledge and experience and the research work which you are presently pursuing at USA. Thank you very much. Over to you, sir. Sir, we have with us our Honorable Shri B. N. Dikshit, sir. Sir, B. N. Dikshit, sir, let me speak to us.
Yes.
Please, sir, please. Thank you, sir. Thank you.
Very good morning. So this is the continuation of again one more webinar by Dr. Legal Metrology Sri Asutosh Agarwal ji. The webinar is very interesting. Again, the person who is having the full NPL background, he is going to give a lecture and disseminate his different points and his life's other things also. I hope for the successful of the programs. Legal metrology is very vast.
Thank you.
Subject.
Thank you.
Legal metrology is very vast subject. In that many things has been covered because it is full of the instrumentations. And the instrumentations, designs and developments never depends upon the only one technologies. It varies from technologies to technologies. And you feel that we have the electronic petrol pump, so many things. There you'll find the different technologies, different mindset and all that very things you are getting here. With this very word, I wish for the success of the programs. Thank you, everybody.
Thank you very much, sir, for your kind and motivating words. Thank you very much. Sir, this is a very important topic, and we have with us, as I already explained about Dr. Piyush, who is actually kind enough, I think it is a night in US, and he is very kind enough to make this lecture because our time is fixed. 11 to 12:30. So I requested him to be kindly present at our time, and he kindly accepted us. Thank you very much, sir. Over to you, Piyush, sir, please.
Thank you, Ashutosh ji, for such a nice introduction. And yeah, I'm one of Astosa's student. Hello,
Sir, yes, sir,
hello.
please continue. You are audible. Please continue.
Yeah. So now let me go to my slides. Are these visible to you, everybody?
Yes, yes, very well. Please continue.
Yeah. Yeah. So today's our topic of discussion is ultrasonic entity, legal metrology, implementation of for inspection accuracy. Now, in this, I will try to introduce you about the ultrasound, its application, and especially to non-destructive testing. Now, the non-destructive testing is a very vast area, so I will try to focus on the one topic, that is concrete structure. So, ultrasonic concrete structure inspection using the ultrasonic pulse velocity measurement instrument. After that, I will also give some importance of ultrasonic entity with the legal metrology. And now, the ultrasonic pulse velocity measurement has many techniques, so I will explain two techniques here. And also, I will discuss about the development of these both technologies, and I will also try to compare both the technologies so that we can know about the accuracy of these both technologies. And after that, I will also discuss about the reference standard for the ultrasonic pulse velocity measurement instrument, which is used for the calibration of this instrument. Now, what is ultrasound? First question I'll always in mind in everybody's. So, ultrasound is a mechanical wave that will need a medium for the propagation. So, ultrasonic wave has frequency greater than 20 kilohertz. It is not audible to human. Ultrasonic wave can be generated with the help of suitable transducers like piezoelectric disc and EMET, etc. So this ultrasound has two basic parameters: attenuation and velocity for the measurement of any kind of information from the medium. Uh, So the ultrasound has a wide applications like in metrology, material processing, biotechnology, and non-destructive testing. So this ultrasound application is divided into two parts. First is the lower range of ultrasound, that is 20 kilohertz to 500 kilohertz, and second one is the zero point 0.5 megahertz to 10 megahertz, which is used to inspect steel, iron, even the human organs. And the lower range is used for the concrete structure, wood, rubber, and rocks, which are the porous materials. Now, I would also like to introduce you to the non-destructive testing. Now, if somebody has a kidney stone, like he has doubt, so what, like if he go to the hospital and doctor say him like go to the surgical department and let's open your kidney to check your kidney stone, like nobody is going to going for that. So we have a technique, the ultrasound. So by using that ultrasound we can check the kidney stone. And the second one is the concrete structure, like you are sitting in a building and somebody came and used a hammer to try to break that concrete and check their quality, or someone can wait a earthquake to check this quality. But we have another technique, that is ultrasonic pulse velocity measurement technique, which is used for the concrete structure. So basically, the destructive technique is not useful, but non-destructive testing is useful to measure the property of any material without disturbing its natural property. Now, the ultrasonic concrete structure, uh, like could be uh, the strength of the concrete structure could be measured with the help of ultrasonic pulse velocity measurement technique. But before that, we have to know about the relationship between the ultrasonic pulse velocity measurement and the material property. When an ultrasound introduces the n material, it will reflect from the many faces of the material, and this ultrasonic wave can be received with the help of another transducer. The point is here, like this ultrasonic pulse velocity is independent to the geometry of the material, but it's depend on the elastic property of the material, like Young's modulus, Bulk's modulus. So in case of concrete, we can measure this dynamic sense modulus of velocity, which is the measure of strength of any material. Now here a few equations by which we can measure the ultrasonic pulse velocity. Now what is this ultrasonic pulse velocity measurement? The ultrasonic pulse velocity measurement is a non-destructive technique used to investigate the strength of any material, such as concrete. In case of concrete, by comparing ultrasonic pulse velocity, we can measure the strength of the material by using Indian Standard 516 Part 5 Section 1. Here in figure 2, everybody can see, wait, like if the ultrasonic pulse velocity is less than 3 kilometer per second, then it's in the doubtful category. So we have to reject that concrete structure, like we have to use that building. And if the ultrasonic pulse velocity is greater than 4.4 kilometer per second, then it's in the excellent quantity. So that means we can use that concrete. Now these are the few available technology in the market uh, with their specification and features. So here, like if we require a high resolution to measure, we can use this chromosonic product. If we required online data transfer, we can use this Metas UPV. If we required high transit time range measurement, we can use this Pundit Lab Plus. And if we required high bandwidth, we can use this Pundit Lab PL200. And this is one of the Indian technology in the last. Now, metrology. So every measurement, like our weight, can be measured in the kilogram, but nobody knows how we measure this kilogram. So every measurement has a unique method and science behind it, which is called as metrology. And this metrology is divided in three sections: science, scientific metrology, like CSIRNPL is maintaining and developing these measurement standards. Industry metrology, it's ensure the adequate functioning of measurement instrument used in the industrial production and testing laboratory. And that one, the legal metrology, which is very important. This ensure the regulatory requirement for the measurement and the measuring instrument, which is useful for health, public safety, taxation, and protection of the consumer and fair trades. Now here you can see below two pictures, figure 3 and figure 4. In figure 3, you can see a collapsed bridge in Bihar. So there might be a cause of wrong measurement of ultrasonic pulse velocity uh, by like so if somebody measure the ultrasonic pulse velocity accurately, then this couldn't be happen. And same case in Delhi, you can see here this a building is collapsed here. So this ultrasonic pulse velocity measurement is very important, and the legal metrology is play a very crucial role here. Now there are two techniques to measure the ultrasonic pulse velocity. First one is the pulse echo method, and second one is the through transmission method. So concrete is a highly porous material, so it's required high power, like in kilowatts, and it's required low frequency, which is the range of 20 kilohertz to 500 kilohertz. So in pulse echo method, here we can see that a pulse is reflected from,
Sorry, sir, for interruption.
yeah,
Your slide is not moving, sir.
it's not moving.
Yes, sir.
I Yeah, I'm on the eighth slide, right?
No, sir, but it is visible only one slide.
First slide.
Yes, sir. We are
Uh,
mentioning your introduction.
oh man, wait,
Yes, sir. Yes, sir.
sorry.
So actually, we thought that you're at the first slide, or you're just explaining before that.
Oh no, I'm on the eighth slide of my PPT. I think I should my screen full screen, right? Now it's visible, or should I start again?
Not yet.
Okay. So I'm starting from the eighth slide. Okay.
No, but slide is not visible.
Right now.
Yeah.
Oh, sorry. I don't know how. Like I'm try to share it, but it's not happened.
You can WhatsApp it to me.
Yes.
Atulji, I will share it to you so that you can immediately start, or you can share it with Atulji, anyone, so that he can
Okay.
start from there.
Okay.
Sir, once the unsaid and then
Like I'm calling you. Can you attend this call, please?
Still, it is not visible. Atulji, please try to help him to be in.
yes, sir, we are trying to. ये सर मीटिंग लिस्ट कर रहे हैं क्या सर? You sir, please share your PPT.
Now it's visible.
Yes, sir, visible. Yes, sir.
It's
Please.
changing.
Yes, sir, changing, sir. Perfect, sir. Continue,
Okay.
sir.
Okay. So now I'm starting again from the eighth slide. So ultrasonic pulse velocity measurement has two techniques. So first one is the pulse echo method and second one is the throw transmission method. In pulse echo method, we receive a ultrasonic wave from the same transducer which is producing it, and we can measure the ultrasonic pulse velocity by using same simple formula v is equal to 2 dt by t. And second one is the throw transmission method. In this method, we have a electronic timing circuit, which is start when the electric pulse generator gives a start signal to the electronic timer, and it generate a excitation pulse on the same time, which is used for the excitation of this transmitting transducer, and this transmitting transducer produce ultrasonic wave inside the material. This ultrasonic wave will receive with the help of receiving transducer, and this receiving transducer produce an electrical signal for the receiver. This receiver signal amplify the signal and give it to the electronic signal to stop electronic timer to stop the electronic timer, and the electronic delay will display in the display section. And we can measure this ultrasonic pulse velocity by using this simple formula. Here, d is the length of the specimen. Now, this ultrasonic pulse velocity by using through transmission method has three methods based on the position of transducer. First one is the direct method. In direct method, we place transmitting transducer is just opposite to the receiving transducer. In indirect method, second one is the indirect method. In the indirect method, we place both the transducer on the same plane of the sample. In the third semi-direct method, we place transmitting transducer is just adjacent to the receiving transducer, and we can measure ultrasonic pulse velocity with the simple formula V is equal to d by t. Now you can see d we can measure with the help of a scale. By using scale, we can measure the length of the sample, and this time is very important factor now here. So there are two methods for the measurement of this transit time. First one is the counter method, and second one is the data acquisition method. In counter method, as shown in the figure 8, we can see the a timer is start in the beginning of the transmitting signal as shown in figure, and it's stop uh, at the beginning of the receiving signal. In data acquisition method, the entire signal, the transmitting signal and the receiving signal is acquired with the help of analog to digital converter, and by analyzing it, we can measure this transit time measurement. Now, CSI and NPL developed two technologies. In this section, I will try to explain you how these works and how we can measure the ultrasonic pulse velocity with the help of both two transducers. So these initially the available ones generate an error up to 10%, and the developed one produce a 0.4% error with an accuracy of 100 nanosecond. And these are the key feature of the both instrument, that like the counter method has automatic threshold error correction, which I will explain in the later slides. It has a transit time measurement range from 0 to 15 millisecond, which is not available in the previous one. It has world's finest resolution, which is 50 nanosecond, and in the averaging mode, it is 10 nanosecond. So it has three averaging mode, 1, 5, and 10, and we can select multiple gain in steps of 25, up to 2500. So we can go up to 2 meter or 3 meter with the help of this instrument. So this instrument has a wide range of frequency, which is 20 kilohertz to 200 kilohertz. So that means it has all the feature of the available instrument. And the second one is the um, ultrasonic pulse velocity measurement instrument based on the analog to data acquisition method, which has the additional key feature to the counter method, which is wave analysis. So we can analyze the wave, and it has the capability to acquire the signal, and it can store the reading for the future reference. And its effective resolution is 10 nanosecond at a lower sampling rate. And we can see later we required a high sampling rate to achieve this uh, resolution. So this is the comparison between the conventional and the developed ultrasonic pulse velocity measurement device. In the conventional method, we have a timing circuit which gives a trigger to the transmitter. Transmitter excite this transmitting transducer. Now I'm not going to explain it again. I already explained. Now what is the problem in this? So to stop any timer, we require for the stop to stop any timer, we require a digital signal, and that digital signal we can get from a comparator. So we have to compare our analog signal with a threshold voltage. So this threshold voltage, here you can see that ideally we have to stop our counter at T0 here. But due to threshold voltage Vt, this uh, stops at T1, which produce an error from T1 to T0. And it is varies with the gain. Gain it's depend on the amplitude of the receiving signal. So these are the issues in this present instrument which produce 10% error in the measurement, which is very huge. So we develop a technology with the uh, two threshold comparison and two counter technique. With the help of this technique, we achieve a 0.4% reduction. Like this instrument has only 0.4% error. So this is very good. Uh, like we can't say good, but this error is very less. Now, how we measure this ultrasonic pulse velocity measurement by using this ultrasonic pulse velocity tester. Now, this is the setup. Here, this is the ultrasonic pulse velocity tester, and we are going to measure ultrasonic pulse velocity in this perspex blocks, which is the standard block. And this is the transmitting transducer, this is the receiving transducer, and we need a coupler. Since this is a battery operated instrument, we switch on our instrument, and as both the transducers are separated, we can see that this instrument is searching for the signal. Now I'm placing some couplant so that ultrasound can transfer into the material properly. Now I'm joining both the transducer so that I can tear off offset in the instrument by pressing the middle button here. Now I'm placing the sample in between the both transducer. Now here you can see it's showing the delay inside this material, and you can see also the resolution. It is 50 nanosecond. Now this is the conventional setup for the ultrasonic pulse velocity measurement using data acquisition method. Here a digital oscilloscope is used to acquire whole signal from transmitter and the receiver, and we can measure the transit time as shown in the figure. So this is has same problem as the previous one, but it's like method is different in both cases. So previous one required threshold comparison. Now we have to choose a threshold point to uh, uh, to to measure this ultrasonic pulse velocity, and this required also a fast ADC with a fine for a fine resolution. So in the developed instrument, I'm using only 32-bit microcontroller, which is used to acquire this transmitting signal and the receiving signal. And we develop a software for this. This is the software where we use a two-point detection technique to reduce and minimize this threshold error in the measurement. Now this is now how we can measure the ultrasonic pulse velocity by using this instrument. So this is the setup. Again, this is the software we develop. Now I'm connecting this module. This is the developed module with our computer. Now you can see, like previously, it's searching again for the signal. Now I'm placing both the transistor together and attaching together to offset measurement. Now here we can convert it this continuous wave into the sample to detect two points. Now I'm placing the transducer in between the transmitting transducer, receiving transducer. And now I'm trying to adjust our gain to detect this linear point. Now the green mean it's showing correct reading. So in previous device we can't see like this the wave and this whether the reading is right or wrong we can't say in that instrument. Now I'm going to compare both the instruments. So what is the accuracy of these instruments? So I'm going to measure the ultrasonic pulse velocity in these blocks. These are the perspex blocks, standard blocks. Now the counter method has two errors. First one is due to the crystal accuracy, and second one is the error due to threshold voltage comparison. This threshold voltage comparison I'm already explained, and every timer requires a crystal to measure the time. So this crystal, produce a error into the measurement, but we can reduce by using a high accuracy crystal. So here you can see that the higher accuracy crystal producing a lower error in the measurement. And the same data acquisition method has two errors due to the effective of sampling rate and due to the ADC resolution. Here we can see that we require a high resolution to minimize our error. So in the 1 mega sample, we get an error of plus minus 1 microsecond, which is very huge. And this ADC resolution, so the ADC resolution is not much affecting our measurement. So we can set at 8 bit also. Now we try to measure our ultrasonic pulse velocity with the help of both transducer, like both instruments, on different averaging mode. So here we can see that by increasing the averaging mode, we get a lower standard deviation in the measurement. And by increasing the sampling rate in the analog to data acquisition method, we can see we are getting the lower standard deviation in the measurement. So table 5 is comparing both the measurements, and table 6 shows the measurement of this accuracy. So here we can see that the analog to data acquisition method has lower error in the measurement, which is very low. But also we can see that the both the instrument has lower error in the measurement. Like they both has better uncertainty in the measurement, which is like both are good. So this reference material is used for the in this slide I'm going to present this reference standard. So according to the IS 516 and ASTM C597, both the instrument need to be calibrated with the help of this calibration block. So these calibration blocks has some issues like ultrasonic pulse velocity changes in these blocks with temperature. As we can see that from the figure 24, that with the increase in temperature, the ultrasonic pulse velocity is getting decreased. So this is a very big error in the measurement. And also this small one B3 is only for the 25 microsecond measurement, but the standard says we required a block from 20 microsecond to 10 millisecond. So and this big one B1 is about 100 mm length. So it's a very big um, sample only for the 100 microsecond. So you can imagine how much big we required for the 10 millisecond, which is even not possible practically. So and also we require a different frequency transducer for the uh, measurement of ultrasonic pulse velocity in the different category of the concrete as per the Indian standard 516 and ASTM C597. For that, to mitigate these issues, I have developed an instrument that electronic delay, which is mimicking the property of this calibration block. which is not affected by the temperature variation. So these are the advantages in this using this electronic delay reference standard. This is the suggestion here. So this can go up to 20 degrees Celsius to 70 degrees Celsius, and it has the wide range of delay from 20 microsecond to 10 millisecond. And this has wide frequency range, like we not need to required for different frequencies transducer to calibrate our transducer, this instrument. Here you can see that and it is very compact and easy to carry. So this is a good product for the industry also. So these are the key points in our uh, seminar here. So ultrasonic pulse velocity is used to measure the concrete grading as per IS 516 and ASTM 597. Ultrasonic NDT and legal metrology is very important for the life safety, as we can already see in our slides. And threshold error correction improves the ultrasonic pulse velocity measurement. Ultrasonic pulse velocity measurement carried out with the help of data acquisition method has better uncertainty than the counter method. We required certain reference materials for the calibration of this ultrasonic pulse velocity measurement instrument. And we can use a wide range electronic delay for the reference standard at any temperature. Thank you. Questions and suggestions are welcome. Hello.
Yes, sir.
Yeah. So, sir, you can see your photo here.
Okay.
Yeah.
Thank you. Thank you very much. I think you want to share something else, or your presentation is over?
Yeah, it's over.
Okay. Thank you very much,
Yeah.
sir. Thank you. I would like to request all the participants to kindly switch off their mic and switch on their videos so that we can take few photographs. So, what is the conclusion of this particular webinar? Can you please
Okay.
give us
Yes,
in
yes,
three
yes.
lines?
Right. So, like particularly this seminar is for the to tell the peoples about the ultrasonic NDT importance, and the for the legal metrology also, like how legal metrology is important for to aware the peoples. Like, you know, nobody knows about this instrument. Okay, but by this webinar, now everybody knows about this instrument. Like nobody knows how we measure the strength of the concrete structure. Okay, now everybody knows how we can measure this strength of this concrete structure with using this ultrasonic pulse velocity measurement. So this is the ultimate goal of this seminar.
Thank
And
you.
also,
Thank you.
yeah, also we should always try to use the reference things. So this is the main point.
Okay, thank you very much. Thank you. I would like to request you to kindly share your presentation with us so that we can share it on our website. And this video will
Okay.
also be available on the website. Thank you very
Okay.
much. Atulji,